So as Corey just said, I'm going to be talking about manatees, seagrass, and sea level rise in the northern Indian River Lagoon, more specifically in Florida. So I'm going to start off with some cool facts about manatees, because they're cute, and because it'll be helpful to better understand my research and its finding. So the species of manatee that's found in the United States is the West Indian manatee. They are mainly found around the state of Florida, but their range is expanding towards the Gulf of Mexico and towards some northern states because of increased temperature due to climate change. They are pretty big marine mammals. They can weigh up to 450 kilos and measure to 3 meters long. And they are called the sea cows because they are exclusively herbivores. So they feed on seagrass and sometimes algae when there's no seagrass available. And they eat quite a lot of it because they can eat up to 8% of their weight in seagrass a day. So if a manatee weighs 450 kilos, that is 36 kilos of seagrass per day. However, that seagrass that they're feeding on is threatened by sea level rise. On the right, you can see a plot of seagrass density around the state of Florida as a function of depth. And what we can see is that seagrass mainly grows in the very shallow areas that are less than 2 meters deep. That is because seagrass needs light to grow, and as depths absorb light, it can only grow in the very shallow areas to get the sufficient amount of light that it needs. However, that is threatened by sea level rise and by a phenomenon called the coastal squeeze, and this video is going to show that to you. So this is the current day situation with a pretty healthy seagrass bed, growing mainly in the shallow areas of the ocean. And as sea level rises, it is expected that that seagrass bed is going to migrate on land to follow the shallow areas of the water and stay within its depth range. So you will see that in just a second. The seagrass bed just migrated and stayed on the coastline, but it's still the same healthy seagrass bed with the same coverage. So that would be the ideal scenario, but it's not what's happening because we build cities on most of the coastlines and protected those cities with dikes or seawalls or any types of coastal mooring structures that are preventing the water to flood into the city. So because of that, the water is not migrating on land, it is rising, which is causing a contraction of the depth range of seagrass and ultimately causing seagrass loss. So why is that important, especially for manatees in Florida? Manatees have faced several mass mortality events in the last decade or so. For example, in 2021, over 1,000 manatees died, and most of them died from starvation or malnutrition. When we know that the manatee population is about 6,000 individuals, that represents a pretty good chunk of the total manatee population. So some organizations, such as the Florida Wildlife Commission, have created feeding programs for manatees where they feed them with lettuce to prevent starvation. But those programs are not sustainable and viable for long term. So understanding how seagrass coverage will be impacted by climate change is going to be important to protect manatees and guide the conservation effort. So that leads me to my research question. How will future climate change trajectories influence manatee seagrass habitats in the northern Indian River Lagoon in Florida? So the Indian River Lagoon is located on the Atlantic coast of Florida, right between the northern border and the southern tip. My study area, which is depicted in blue on this map, is made of 3 main waterways, so the Banana River, the northern part of the Indian River, and the Mosquito Lagoon. All these waterways are connected to each other through inlets, and they're also connected to the ocean. The Indian River Lagoon is a wetland type of ecosystem, so it is made of very different types of wetlands, going from salt marshes to tidal marshes or mangroves, but I'm going to discuss that in just a few slides. It is a very interesting place when studying manatees and seagrass. As you'll see in this video, it has many healthy seagrass beds that are home to many species, not just manatees, but fish, and that are important for the resilience of the ecosystem and for carbon storage. The Indian River Lagoon is also interesting for manatees because it is one of the places in Florida with the highest manatee abundance year-round. So that's why I chose to focus on the northern Indian River Lagoon. So to answer my research question, my process was made of 3 main steps, and I'm going to go over the finding of each of these steps in the following slides. So first, I had to create high-resolution maps of predicted temperature and depth under different climate change scenarios. Then I modeled how seagrass coverage would change in these different climate change scenarios. And finally, I assessed the seagrass areas that would be reachable by manatees for each of these scenarios. So first, how is climate change going to be impacting the lagoon? For that, I used 4 climate change scenarios that were created by the IPCC, and they're called the shared socioeconomic pathways. So going from 2.6 to 8.5. The 2.6 scenario is kind of the best case scenario. It's the lowest emission scenario in which emissions reach net zero by 2050, while 8.5 is the worst case scenario in which emissions go unmitigated. So here you can see predicted changes in temperature for the northern Indian River Lagoon by 2100. So to get maps of predicted temperature in the area, I used those predictions and applied them to a map of mean annual temperature in the area between 2008 and 2020. So that gave me 4 different maps of predicted temperature in the lagoon in each of these scenarios by 2100. Then I had to do the same thing for depth. Here you can see a map of current depths in the lagoon. The Indian River Lagoon is a pretty shallow area, as the mean depth is about 2 meters. There are some deeper areas, especially in the Banana River, where there are some areas that are 10 meters deep, but there are only a very few of them. So as I mentioned before, the Indian River Lagoon is a wetland type of ecosystem, so sea level rise is not impacting wetlands the same way as it is impacting dry land. So to understand how sea level rise was going to be impacting that ecosystem, I use a model that is called SLAM. It stands for Sea Level Affecting Marshes Model, and it uses information of depth, slope, and wetland type to assess how sea level rise was going to impact the ecosystem. So in that case, there are 4 different sea level rise scenarios going from 0.58 meters to 0.91 meters by 2100. So that gave me maps of predicted temperature and depth for each scenario, and I used these maps to predict seagrass habitat suitability in the northern Indian River Lagoon. For that, I used another model called MaxEnt, and that model uses information of current seagrass coverage as well as current depth and temperature to assess how predicted temperature and depths are going to change the seagrass habitat suitability. So seagrass habitat suitability is basically where seagrass is likely to grow. So 1 with a high predicted probability of it being suitable in that scenario, and 0 being the lowest probability. So here you can see the predictions of the model for the lowest emission scenario by 2050 and 2100. What we can see is that it looks pretty similar to the current seagrass coverage, with mainly the coastal and shallow areas being highly suitable for seagrass. That can be explained by the fact that this scenario is the lowest emission scenario, so there are not much changes in temperature and depth between now and 2100, so not much changes in seagrass habitat suitability by then. The picture looks different when looking at the 8.5 scenario, so the highest emission scenario, especially for the 2100 prediction. We can see that the areas that are predicted to get flooded by sea level rise in that scenario are also the area with the highest predicted probability of being suitable for seagrass. One other thing that we can notice is that the Banana River, that is the waterway with the highest seagrass coverage in the current seagrass coverage, doesn't actually have a high predicted probability of being suitable for seagrass by 2100. So that can be explained by what I mentioned before, the coastal squeeze. So Banana River is surrounded by urbanized area. On the east bank is Cape Canaveral, so a city, and on the west bank is the NASA Kennedy Space Center. So here's a good example where water cannot migrate on land. It can only rise because it cannot get into these areas. So that's causing a contraction of the seagrass range and can explain why we have this low predicted probability of seagrass habitat suitability. We can take a look at numbers and see what it looks like. So I'm going to guide you through that figure. You can see here on the y-axis is the total seagrass area in kilometers square for each of the scenarios that I modeled, and for 3 predicted probability thresholds, going from 50% for light green and 95% for dark green. The dashed line represents the current seagrass coverage in the lagoon. So what we can see, and the main pattern, is clearly that as emissions increase and as the climate change scenario worsens, there is an increase in total seagrass coverage predicted. But in all climate change trajectories, the total seagrass area is predicted to be higher than it is today. So there should be an increase of total seagrass coverage in the lagoon, no matter the climate change trajectory. However, all that seagrass is not available to manatees. Manatees, just as all organisms on the planet, have a preferred habitat. That means they have a place where they would rather stay and where they are the most likely to be found. So I had to assess their preferred habitat for temperature and depth. So for temperature, it is known that manatees cannot be in waters that are below 20 degrees Celsius because they have a very low metabolic rate, so it would put them at risk of dying of cold stress. So I know that this was the minimum thermal limit, but I had to assess what the upper thermal limit of the manatees' depth temperature range was. For depth range, as you can see, compared to 2 divers, they are pretty large marine mammals. So accessing very shallow areas is not a part of their preferred habitat because they cannot swim in these areas. They would have to crawl, and that's not a comfortable place for a manatee to be in. So to assess their preferred habitat, I used data of manatee distribution around the state of Florida and combined it with temperature and depth. So we can start off with temperature on the left. What strikes out is that there are no clear patterns. Manatees do not seem to have a preferred range of temperature. And that was confirmed by a review of the literature that showed that manatees do not avoid very warm waters, even in the event of extreme heat waves. So it was decided that all the areas that were above 20 degrees Celsius were a part of manatees' preferred habitat. For depths on the right, manatees are mainly found in the very shallow areas that are less than 3 meters deep. That can be explained by the fact that they spend a lot of time grazing on seagrass. So basically where seagrass is, manatees are too. Especially the highest manatee density is found between minus 0.5 and minus 1.5 meters. So that was once again confirmed by a review of the literature showing that manatees have an aversion for very shallow areas. So it was decided that all the seagrass areas that were less than 0.5 meters deep would not be a part of manatees' preferred habitat because they could not swim and get comfortable in these places. So using that preferred habitat, I identified for all predictions the areas that were outside of that preferred habitat. So those areas are depicted in red on this map. So what we can see here for the 2.6 predictions is that it gets better actually between 2050 and 2100 for manatees. That is because the water is predicted to rise by 2050, but the newly flooded areas will be too shallow for manatees to get in. But by 2100, as the water will rise even more, those areas will get deeper and manatees will get access to these areas. For the 8.5 scenario, the picture is different. What we can see is that the areas with the highest predicted probability of being suitable for seagrass, so over 95% in purple, are actually the areas with a big chunk of them that's not reachable by manatees. That is because they get too shallow, so manatees will not be able to access these areas. So once again, we can look at numbers. This is a pretty similar figure to the one that I showed before, except that it's not showing the total seagrass area. It is showing the seagrass area available to manatees in each scenario. What we can see are very similar patterns. As emissions increase, the predicted seagrass area available to manatees increase too. And similarly, there will be an increase of seagrass coverage available to manatees compared to today. So that suggests that there will be an improvement of the manatee seagrass habitat, no matter the climate change trajectory. So what do those findings mean for conservation? First, there are many seagrass restoration projects happening in the northern Indian River Lagoon, where they transplant seagrass into the lagoon. Those projects should take into account that predicted seagrass habitat suitability to ensure that when seagrass is transplanted, it is transplanted in areas with a high predicted probability of being suitable to ensure that there is a long-term viability of the project and that the seagrass can grow for a long time period. For manatees, it means that we should keep tracking them, tracking their distribution and their feeding habits to ensure that we can anticipate or prevent any starvation or malnutrition events. This study is only the beginning, and there are many further studies that could be taken to improve our understanding. First, this framework could be used for other environmental variables, such as salinity, which is known to highly impact seagrass growth. It could also be used for other temporal and spatial scales. Especially, there are many changes in seagrass coverage between the winter season and the summer season in the Indian River Lagoon. So assessing how seagrass coverage will change seasonally in each climate change scenario will be helpful to understand how the manatee's habitat will be evolving. Further studies could also integrate risk and impact of extremes events related to climate change. Especially, the northern Indian River Lagoon has faced several harmful algae blooms since 2011. Those blooms form mat at the surface of the water, which is preventing the light to get in, and so it's preventing seagrass growth. So assessing how the intensity and frequency of those blooms will be impacted by climate change will be helpful to understand how seagrass coverage might be impacted. And finally, further studies could also assess the manatee's carrying capacity of the northern Indian River Lagoon to understand how many individuals and what proportion of the manatee population that ecosystem could sustain for a long time period. I would like to finish with some acknowledgement. I want to thank my Capstone committee, both Dovi and Solène, for their guidance and expertise, but also for their kindness and care. I want to thank the people that helped me along the way, Doug, Jane, and Holly, especially for guiding me throughout the manatee knowledge. And finally, a special thank you goes to Corey and Hannah, also my CSP peer. Thank you for this great year of learning. And to all my close ones, the ones here and the ones on the live stream, thank you for your love. And I'll finish with a manatee video. Thank you all, and happy to take any questions. Done.
Great job, Anaïs. That was awesome. Is the difference in seagrass growth between winter and summer, is that temperature related?
Yeah, it is mainly due to temperature. So the seagrass coverage is higher during the summer season because temperature is higher, so that promotes more seagrass and more seagrass growth.
So based on the amount of awes you got with some of the manatee pictures, obviously a lot of us are animal lovers, and therefore motivated to protect species like manatees. But what would you say to somebody who isn't motivated by just like their cuteness? Like what level or what position do they play in the greater ecosystem?
So, I mean, I'm a firm believer that manatees can exist just because they are here, and that's the case for any species here. So I don't feel like they should get a purpose to actually exist and for us to actually protect them. But they're also very important, especially for seagrass growth, because they graze so much on the seagrass. It promotes seagrass growth faster, so they actually help the ecosystem. And we know that seagrass is very important for carbon storage, but also ecosystem resilience. So they are part of the whole seagrass cycle and carbon cycle. So they are very important in the Florida ecosystem.
That was a really great talk, Anaïs.
Thank you.
Yeah, you packed a lot of work in a very short time. Nice job.
Thank you.
I was wondering, in your models, you had sea level rise, you had the water warm up, but you didn't really address one of the scenarios that you put forward at the beginning, that there's these seawalls, the squeezing, and could you have blocked out some of the areas so that the sea level couldn't actually rise to them? And, you know, you made climate change kind of look good. We're going to get more manatees, yay.
Yeah.
But, you know, if you do put your seawalls in there, does that change?
Yeah, so those scenarios actually take into account seawalls. So there are not a lot of seawalls in the northern Indian River Lagoon right now. But the SLAM model that I used to predict how sea level rise was going to be impacting the ecosystem has several parameters. And I chose to protect all developed dryland, so it couldn't flood past the roads or past the cities. So yeah, so there are not much dikes or seawalls, but that scenario and those predictions did take into account how, if we build dikes to protect each urbanized areas, what would happen. Yeah, still. All right, thank you.